All right, so let's go back to that question 22 where it talks about the log. This is a lot of a question, so I wanted to kind of not do it in the last video, and I wanted to do it to kind of start fresh. All right, so John is building furniture using cylindrical logs of length 1.8 meters and a radius of 9.2 centimeters. Now, we have to be careful. I don't know if you noticed in the volume questions, units are a big deal, okay? They kind of like to trick you. So this is in centimeters and this is in meters, okay? A wedge is cut from one log and the cross section of this log is illustrated in the following diagram. All right, so the first part, we want to find the length of the wedge arc ABC. Okay, so we want to first find the length of this arc right here. All right, so now remember to find the arc of the length of an arc is your central angle. So in this case, our central angle is 100 over 360 times the circumference of the entire circle. So remember, circumference is 2 pi r. So 2 pi times a radius, which is 9.2. Okay? So let's put that in our calculator. So 360 times 2 pi times 9.2. Okay, so the length of our arc is 16.05702912. Okay. Now, we want to find the area of the empty sector, this part right here. So we want to find the area of all of this. Okay. Now remember, to find the area of the sector, we do the same thing, but we multiply it by the area of the circle. Okay, so central angle over 360 times the area of whole circle. So pi radius 9.2 squared. Okay. Times so the area of this sector, empty sector, is 73.862339. Okay. Now we want to find the volume of each log. So we want to find the volume of this whole thing. All right. Now here's the weird thing: we are not using our normal, even though it is a cylindrical radius times the height. We're not necessarily using this formula. We're using like a variation of this formula. Okay. Now the weird thing about a cylinder, not the weird thing, but the thing about the volume for a cylinder is that this is actually kind of the area of the base. Okay, so you know how our prism volume formula is the area of the base times the height? This is kind of the same thing, except because the area of the base is pi r squared because the base is a circle times the height. Okay, now we have to be super careful with this though, because the area of the base is this part. Okay, now it is not including the yellow part because that part is cut out. We cut that out. We're not including that. So we need to find the area of the blue part, and then we're going to multiply it by our height of our cylinder or our log. Okay, so let's first find the area of our shaded sector or sector part, or blue part. Okay. So we need our central angle. So now it's 360 minus 100 is the central angle of that. So our central angle is 260 over 360 times our area of our circle, so pi 9.2 squared. Okay. Which gives me 260 over 360 times pi times 9.2 squared. So that is approximately 192.042063. Okay. Now, we're going to take this and we're going to multiply it by our height. Now, we have to be careful. Our height is in meters. We have to convert that to centimeters, the length of which is the units our radius is in. Okay. Now, 1 meter is equal to 100 centimeters. Okay. So this is 1.8 times 100 is 180. So this is 180 centimeters. Okay. So we're going to multiply this by 180 to find the volume. Okay, so times 180. So our volume is going to equal 34567.572229 centimeters cubed. So before we go on, let's actually maybe write this conversion on our front sheets of our paper, on the front of our packet. It is not a bad conversion to know, and I don't think you are given it on your reference sheet, so this is hypothetically something you might need to know, okay? Okay? All right, let's go to the next question. All right, so here we have a water tower, and the picture below is modeled by the two-dimensional figure beside it. The water tower is composed of a hemisphere, a cylinder, and a cone. Okay, so we have a cone, which is this part. We have a cylinder, which is this part, and we have a hemisphere. Okay. Now, C is the center of the hemisphere and D is the center of the base of the cone. So if AC is 8.5 feet, so AC is 8.5 feet, so this is the radius of the circle. So this part is 8.5 and this part is 8.5. All right, so this is also 8.5. BF is 25 feet. Okay, and the measure of angle EFD, this one's 47. We want to first determine, state to the nearest cubic foot the volume of the water tower. Okay, so the volume of the water tower is the volume of the cone, what's highlighted in orange, plus the volume of the cylinder, plus the volume of the hemisphere. All right, so volume of cone is 1/3 pi r squared times the height. Now we have the radius, but we need the height. Now, because we were given an angle, we have to use SOHCAHTOA. Okay. So here, gosh, here is the triangle. Here's 47. Here is 8.5. All right, so opposite, adjacent. So we're gonna use tangent. So my height is equal to tangent of 8.5. Now my height is the opposite, so this would be over 8.5. Okay, so H is going to be equal to tangent of 8.5 times, oh my gosh, this is 47. Sorry. So tangent of 47 times 8.5. Okay. All right, so now we're gonna plug that in. So our radius is 8.5 times the height is tangent of 47 times 8.5. Okay. Now, we're going to add this to the volume of the cylinder. Now, volume of cylinder is pi r squared times the height. So pi, our radius is 8.5 times our height, which is 25. Okay. That was pretty simple. Now our hemisphere, half sphere, whatever, is this. So pi r, no, that's not the volume of the sphere. So volume of a sphere is 4 over 3 pi r cubed. Okay, so 4 over 3 pi, radius is 8.5 cubed. Okay, so we're gonna add this all up and find the volume. All right, so volume of cone. Let's do that first. Times 8.5 squared times tangent of 47 times 8.5 equals. Okay, so volume of cone is equal to 68.9.6512514. And the volume of cylinder is equal to pi times 8.5 squared. Oh my Jesus, okay, we're back. Times 25. So 5674.501731, and then the volume of the half sphere is equal to is equal to 2572.440785. Okay, so we're going to add them all up to find the total volume of the water tower. So volume of tower hold up. You know what I did not do? I did not divide this by 2. See? See what happens? Very, 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 very careful, kids. Let's divide by 2. So 1, 2, 8, 6. So this is the volume of the tower. Now let's go back and re-add this. I'm sorry about that. No, that is the wrong number. So this one plus. Now be careful when you do this to make sure you're getting the right number. So this is the volume of the cylinder. The volume of the cone. So volume of the tower is 7650.373375. Okay, so to the nearest cubic foot it is the volume is 7650 feet cubed. Okay, so we're not done that question, unfortunately. The water tower, so the second part of this question, the water tower was constructed to hold a maximum of 40,000 pounds of water. If water weighs 62.4 pounds per cubic foot, can the water tower be filled to 85% of its volume and not exceed the weight limit? Okay, so we need to convert our volume to pounds. Okay, so we're going to take this number, so 7650.373375. Now, you could multiply 0.85 first. Actually, let's do that first. Let's find 85% of the volume. Times 0.85. So 6502.817369. So this is the volume to 85% capacity. Okay. Now we need to convert this to pounds because we need to figure out if it exceeds 400,000 or if it's less than. Okay. So we're going to take this number. Wait, 817369. And remember, when you convert, so your answer goes over 1. Now there are 63 pounds, 62.4 pounds per cubic foot. So we want our answer to be in pounds, so we're going to put pounds on top. And we're going to put cubic feet on the bottom. Okay, because those we want crossed off. We want to get rid of that. Okay, so we're going to take this number, our volume of 85% capacity, and we're going to multiply that by 62.4. Now this is going to equal 405,775.8038 pounds. Now, the question is asking, will it exceed the weight limit? So this is more than the weight limit, so yes, it's going to exceed the weight limit. So this is going to, will exceed the weight limit if it is filled to 85% capacity. All right. All right, let's go to the next page. All right, so a wooden cube has an edge length of 6 centimeters and a mass of 137.8 grams. We want to determine the density of the cube to the nearest thousandth. Now, I briefly explained the formula to you, but density is equal to mass over volume. Okay, so we need to find the volume of the cube, and we're going to take the mass and we're going to divide it by the volume. So let's do that first. Okay, so the mass, no, we need to find the volume, excuse me. Okay, so volume of cube is length times width times height. So 6 times 6 times 6. So 6 times 6 times 6 is equal to 216. All right, so we're going to take our mass to find the density. We're going to take our mass and divide it by our volume. So 137.8 divided by 216. So 137.8 divided by 216. So our density is equal to 0.637962963. Now we need to state which type of wood the cube is made of using the density. So we need to compare our density with any density that is on the table. So we need to figure that out. So let's see. So 0.637962963 0.638. No, this rounds up. So 0.638. So our wood is made out of ash. So the cube is made out of ash wood. Okay. All right, so let's look at 26. So during an experiment, the same type of bacteria is grown in two petri dishes. Petri dish A has a diameter of 51 millimeters and it has approximately 40,000 bacteria after 1 hour. Petri dish B has a diameter of 75 millimeters and has approximately 72,000 bacteria after 1 hour. You want to determine and state which petri dish has a greater population density of bacteria at the end of the first hour. Now, population density is slightly different than regular density, but not really. So population density, we're still going to find it the same, except we're going to use area instead of volume. Okay, so population density has area, regular density has volume. Okay. So since this is obviously a circle, we are going to use our circle formula, area circle formula. Okay. So let's do circle A. Let's start there. Okay. So the mass has 40,000 bacteria. We're going to divide it by our area of the circle. So this circle has a diameter of 51. So 51 divided by 2 is 25.5. Okay. So we have 40,000. 1, 2, 3 divided by pi times 25.5 squared. So our petri dish A has a population density of 19.58076,962. Okay. All right, so let's find circle B. So we're going to do the same thing. So we're going to take our population of bacteria and we're going to divide it by the area of the circle. So this has a diameter of 75. So to find the radius, we do 75 divided by 2, which is 37.5. Then we plug that into our area formula, so pi 37.5 squared. Okay, and let's plug it in. 2, 3, pi 37.5 squared. So this has a population density of 16.297466617. Okay. Now they're asking us which has the greater population density. Well, the density for the circle A is bigger, so petri dish A has a greater population density. Okay. All right, so let's look at 27. So we have triangles RST and XYZ are drawn below. If RS is 6, ST is 14, XY is 9, YZ is 21, and angle S is congruent to angle Y. Now they're asking us, is RST similar to XYZ? All right, so like we went over this in class, I believe it was one of the last days when you guys get questions like this, is this similar to this? Is this congruent to this? You need to show me like the proportions, since this is similar, and you need to use a similarity reason as to why they are similar, okay? So, this side and this side are corresponding sides, and this side and this side are corresponding sides. Okay, so you need to show me the proportions that the ratios are equal. So 21 over 14 is equal to 3 over 2, and 9 over 6 is equal to 3 over 2. Okay, so their ratios are equal. Now, because of that, because of side, angle, side similarity, these two triangles are similar. Now, we need to say that, obviously. So, triangle RST is similar to triangle XYZ because of side, angle, side similarity. So the ratio of ZY over ST is equal to XY over SR, and angle S is congruent to angle Y. Okay, so this is what you need. Now, it does say to justify. When you guys see justify, that's kind of telling you that you need to use math. Okay, so you need to show me some type of math that they're similar, okay? Not just an explanation, like you need a little more than that. All right. While we're talking about similarity, let's go to question 28, and then we will call it a day for this video. Okay. So in the diagram below, triangle ABC is similar to DEF. If AB is 6 and AC is 8, then which statement will justify similarity by side angle side? Okay, so side angle side similarity. So sides are proportional and included angles are congruent. Okay. So from looking at this diagram, angle A has to be congruent to angle D. So automatically 3 and 4 can be crossed out. Okay. Now, like I said, sides have to be proportional, so their ratios are equal. So let's just choose number 1, for example. So if these two triangles are similar, the ratio of AB over DE is equal to the ratio of AC over DF. Okay, now let's just plug in these numbers and see if that's the case. So 6 over DE is 9 is equal to AC, which is 8 over DF, which is 12. Okay, so let's cross multiply and see if these ratios are equal. So 6 times 12 is 72, and 8 times 9 is also 72. Okay, so since 72 is equal to 72, this proportion works. So choice 1 is our answer. Okay. We're gonna call it for this video. So again, tomorrow I'll have another video that you guys can watch. I believe it's probably gonna be one of the last videos. All right, but just double check, obviously, throughout the weekend. If it is, if I post one more, then watch it. But if not, if we get through the next questions in the packet, then it's the last video. But all right, so just keep an eye out for that. Okay, keep working on your regencies. Make sure you keep studying those important concepts. All right.